chamber so the water doesn't float everywhere. Okay, this is a model showing how big the moon is compared to the Earth. It's where is my globe? Here it is. So the models that I have in here showing the moon compared to this globe, this isn't to scale. The moon is actually only about half this size compared to the Earth. That's a correct to scale version. So that's how big the moon is compared to the Earth. So the moon is much smaller. It's about 1/4 the diameter. So at one time you could fit 4 moons across one Earth. The Earth is much heavier than the moon, so the gravity on the moon is much less. You have about 1/6 the gravity on the moon as on the Earth. 1/6. So if I weighed 120 pounds, which I don't, I would weigh 1/6 of that. Let's say I weigh 180 pounds, which I also don't. 180 pounds divided by 6, what is that? Does anyone know?
30 pounds.
30. I'd weigh 30 pounds on the moon. When it shows the astronauts bouncing around on the moon, they actually have real heavy equipment that they're carrying around. Big things that carry oxygen and tools and stuff. So the astronauts in their spacesuits actually weigh about 350 pounds if they were on Earth. But they only weigh 1/6 of that on the moon, which is like 60 pounds. So it's easy for them to jump around and stuff with all that equipment. This is showing what the moon looks like through a full cycle. The moon approaches the Earth and then gets farther away during its course because the moon is on what's called an elliptical orbit. It's not a perfect circle going around the Earth. It's a flattened circle. So sometimes it's closer to the Earth and sometimes it's further away. And when it gets closer, it obviously appears bigger in the sky. There's a scientific word for this that's slipping my name, but it's in the chapter. Does anyone have the chapter?
What are you talking about?
The scientific word for the moon approaching, getting closer, and then farther. What is it?
Liberation.
Libration. Libration? Is that how it's spelled?
Yes, sir.
Yeah. So the libration is the idea that it gets closer for a while and farther for a while. We're familiar with this because we just studied how Jupiter's moons do that. And of course, when Jupiter has such a high gravity that when its moons get close to it, the moon is squeezed. Do you remember that? We call that tidal heating. Our Earth doesn't have enough gravity to really squeeze our moon back and forth and create tidal heating. But the moon does. You can see the moon getting bigger and smaller in the sky if you look at it night after night and take photographs. You notice how it's big there and then it's smaller? Can y'all tell the libration from looking at that?
Mm-hmm.
Could it be full and smaller?
It could be full and smaller. This happens to show it at its biggest when it's full. But it doesn't have to go like that. At different times of the year, it'll be, different times of the month, it'll be big and small. It's not always big at full moon and small at noon. It doesn't always work. When it is big at full moon, they call it a supermoon. Have you ever heard them say it's a supermoon? Now it happens every 3 or 4 years. It'll just happen to be big at the full moon. And so it appears a little bit bigger in the sky. And there's a lot of stuff that you see online that says it's going to be huge. It's not that much bigger. It's like 10% bigger. So you can see the moon on a normal night and imagine it 10% bigger. That's barely noticeable by the naked eye. But you can see the difference here.
Isn't that like all the folk tales with wolves coming out and stuff on that night?
Well, they say the wolves come out with the full moon. And that's probably true. Wolves are nocturnal, so they're out every night. But you can see better on a full moon, so that does tend to make the animals more active because they can see better.
Right.
Well, I say wolves are not nocturnal. They're not necessarily nocturnal, but they do spend a lot of time up at night. They can also be up in the day. They're kind of like dogs. They can run around whenever it's best. But if it is a full moon, they can see pretty well, and so they tend to be more active. So that's the libration. I thought there was something else I wanted to say here, but I can't remember. This is the near side of the moon that faces us. This is the far side of the moon that doesn't face us. Do you notice the big difference between the two?
Graders.
Watching.
More dark on the near side than on the far side. Why is that? Well, you need to understand this. The dark places are called Maria. Maria is like Latin or Greek for ocean or sea. Mare? Latin. So, ancient astronomers looked at this, at the moon, even with telescopes, and they thought that might be water, that might be an ocean. And so they called it a mare or Maria, and meaning an ocean. So, because it was dark, kind of like the water is darker than the land on Earth. And so they thought it might be water. As it turns out, there's no water there. But they were right in that is a different material there. And what happens is when a big meteor strikes the Earth, it makes a big hole. Or strikes the moon. It makes a big crater. And early in the Earth's formation, in the moon's formation, the center of the moon was hot and molten. Now, since then, it's lost all its heat and it's become solid, and it's not molten underneath this crust. But back when the moon was young, it was molten underneath the crust. And if it got hit by a large asteroid that made a deep dent, that crater would fill with lava. And the lava was dark. So that's why it's dark there. So all the dark areas are old craters that filled up with lava when the moon was molten.
Why is it only on one side though?
Now, it's only on the side that's near us because if here's the Earth and here's the moon, do you remember the moon became tidally locked to the Earth? Where only one face was facing the Earth? And that happened relatively quickly in the moon's formation because the Earth's gravity is really strong and it slowed down the spin of the moon. Stopped it. And so the moon has a single face pointing towards the Earth. And if you can imagine, the moon does have a core of some heavy metals and some sulfur, some heavier particles that are in the middle. Imagine my fist is the core. The core of the moon is pulled slightly toward the Earth. It's offset from the center. Are y'all with me here? The core of the moon is a little offset from the center and it's pointing toward the Earth. That makes everything kind of squashed together on the side of the moon that's pointing toward the Earth. It makes the crust thinner, it makes the mantle thinner, because the core is off center a little bit. You see what I'm saying? So the crust is thinner on the side that's toward the Earth, and the crust is thicker on the side that's away from the Earth. So, if the near side got hit by a meteor, it would penetrate the crust a lot easier than if the far side got hit by the meteor. And so only on the near side do the craters form deep enough to fill up with lava. On the far side, the crust is too thick to make a crater deep enough to get to the molten lava underneath. And so that's why the far side doesn't have any Maria. It was cratered. It is cratered on the far side, just like it is on the near side, but the crust is so thick on the far side that the crater couldn't penetrate the crust. Yeah?
I thought that had to do with since the Earth, it's like kind of pulling towards the moon's also pulling back on the Earth, it's like the core, the rock that's on that side kind of gets pushed out, bulges out, kind of like the tides do on the Earth.
Well, wouldn't it also, if it was just like the tides, wouldn't the rocks bulge out on both sides, like the Earth?
Mm-hmm.
So they think it has to do with the core being shifted. Other questions? Yeah.
Is the core shifted because of like the gravitation?
The gravity of the Earth kind of pulls the core a little bit towards it and flattens out the difference. It flattens out on the layers. So I'm going to exaggerate this drawing, but if you could imagine, here's the moon's layers. The moon's layers would be shifted like this. It's got like a crust and a mantle and an outer core and an inner core. And they're all shifted a bit toward the Earth. The Earth is over here. So the crust on this side, this is not to scale, but the crust on this side is thick and the crust on this side is thin. So if you get a big asteroid impact, here's a big asteroid, boom! You like my sound effects? Mm-hmm. And it makes a big crater like this. If this part is molten, it's going to fill in the crater like that. And you'll be left with a dark area. Same crater happens on the opposite side. It's not deep enough to reach the molten part, so it doesn't fill in. This molten part is dark in color. So you get dark on this side and not so dark on the other side.
So with the dark spots on the dark side of the moon, is it like
really deep?
They must have been a
big, yeah, yeah, big. So that one right there is really deep, and a couple of these other ones. Make sense? Scientists had no idea. They predicted when the first spacecraft flew around the moon, one of the early Apollo missions. They predicted that the other side of the moon would just look just like this side of the moon. Why not? And it didn't. And they were like, "Whoops, we were wrong." And then they had to go figure out why. And this was the best theory they've come up with, as why.
Is it more mountainous this one like
Well, if you think about having a big hole and then a raised area, and by the way, these raised areas are called lunar highlands or lunaterra. Is it terrae? Are y'all looking at it?
It's lunar. Yeah.
Lunar. The raised area is called a lunar highland or a lunar terrae, and the lower area are the craters. So it would kind of seem, if you were walking along the surface of the moon, Sam, it would kind of seem mountainous as you go down into the crater and come out of the crater. These would be very high, mountain-like lips of these craters. But on this side, you do also have craters, but they're not as visible. But yeah, there's all over the moon there's craters which would make it like mountains. Hey y'all, I got the whole world in my hand. I just thought of that. So figured it. Never mind. They've also taken samples of the dark rock and samples of the light rock, and they've dated them. And which do you think is older rock? 10 points if you can guess. Which do you think is older rock? The light rock or the dark rock? Which do you think is older? There's the correct answer. One of the two. This is more evidence that their little theories about the moon is correct. Which is older rock?
Is that what we're going with?
Sure.
Yes, peach is correct.
You believe that too?
The light rock or the dark rock? Which is older? Orange is correct. Blue is correct.
Wait, no.
Green is correct. Purple incorrect. The light rock is older because it's been rock for a lot longer. The dark rock is younger because it came after from an impact that forms rock from molten lava that hardens. So this is older than this.
Is the lava older? Like,
Well, the rock is old. So lava is not rock until it hardens and forms. You see what I'm saying?
yeah.
So the rock is actually, the rocks themselves are old. These rocks are older than those rocks. You can radioactively date them and see that. Another thing that helps scientists measure age is counting craters. Let me ask you this. If a certain area had more craters than another area, like if they count the number of craters on the moon, there's more here than there is there. Why do you think that is? Why would there be more craters here than there? Why would there be more craters here than there are there? Craters come from things hitting the surface. Anybody know? This isn't for points.
Because it's older there.
Because it's older. It's older here than it is here, so it should have more craters. It should have had more impacts. If tomorrow something hit the moon and for some reason filled up with lava, it wouldn't happen, but if it did, there would be no craters on the lava. The lava erases any craters, you see. And then it hardens and becomes smooth, and then new things impact it and cause new craters. So the area that's smoothed out from lava will have less craters than area that never got smoothed out. So you can count craters to estimate age. And they have a system where there's a direct relationship. So they can count the number of craters per 100 miles, square miles, and figure out the age of something. It's a whole science to that. Counting craters and figuring out age. Isn't that interesting?
Yeah.
We know from crater counts that there are way more asteroids in the solar system billions of years ago than there are now. The asteroids kind of got cleared out of the solar system by impacting all the planets. And now there's way fewer. Most of the asteroids are in the asteroid belt and in the Kuiper Belt and Oort cloud. There's very few floating around that aren't in those places. There are some, but not nearly as many as there used to be. There's a crater. This is pretty cool. You see that thing in the middle?
Yeah.
If you drop a stone, let's say a marble, if you drop it into the water, do you ever notice that it makes like a, when it hits, it makes a thing, and then a wave comes up, a little thing comes up in the middle? Y'all know what I'm talking about?
Yeah.
So that's what happened here. A meteor hit, made the whole area, when the meteor strikes the rock, so much heat is released that it all becomes molten for a little bit, just for a few minutes or hours, depending on how big the impact is, or even seconds, depending on the impact. But if a rock, even now, billions of years, when the moon is a cold rock, if it gets hit by a meteor, all of a sudden that area becomes molten, like liquid almost, and it forms a big splat, like dropping a rock in the water, and all of this becomes molten and goes outward, and it erases any craters, and then the middle comes up and then freezes. And so it's molten, and then it freezes, and you sometimes get this middle thing. And that is a huge rock right there. That's like a mountain. If you were walking on the moon, it'd take you all day to climb that thing. This is a big structure. Isn't that cool? So that's another kind of answer to your question, Sam, how there's craters, there's mountains on the moon. Most of them caused by cratering. The moon never had any like plate tectonics or anything, so it didn't form mountains like we form when two plates collide and form mountains. That's kind of how mountains usually form on the Earth. They form mostly on the moon by impacts. There's an up-close picture of some of the Maria. I don't know why I have that picture in there. You know what that is?
It's the first.
Oh, it's like something from us.
It's a footprint from an astronaut. The entire moon is covered in dust, and the dust has a name. It's called regolith. Regolith is lunar dust, and it comes from impacts. The moon gets hit by something, it throws up a bunch of dust into the space around the moon, and that's drawn back to the moon by gravity and lands somewhere on the moon. A big impact will release enough dust to cover the entire moon in a little thin layer of dust. And this dust piles up over the eons. The entire moon is covered in dust about that deep. The NASA scientists, before we ever landed on the moon, were worried that the dust might be so deep that the spacecraft would go to land and would be swallowed up by dust. They thought it might be many feet deep. Some of the calculations were showing that it could be that deep. And then if that happened, it would clog the engines and such that the thing would never take off and all the astronauts would die. Well, they were lucky it was only about that deep, so that didn't happen.
So they just took a gamble there?
Well, they after going around the moon and looking at it and looking at pictures and stuff, they figured out that it wasn't that deep. But at first, before they started the whole process, they were scared. That's how deep it is, and that footprint right there, the cool thing about moon footprints is they'll stay there pretty much forever. There's no wind, there's no rain, there's no animals running around that'll mess that footprint up. The only thing that can mess it up is if there's another impact somewhere on the moon that throws up a bunch of dust, and the dust covers the footprint. But they don't think that'll happen since there's so much less asteroids roaming around the solar system hitting the moon, they think that won't be covered up by dust for millions and millions of years. So whoever left footprints on there, they're going to stay there for a long time. Isn't that cool?
Do they bring a lot of sand and dust back?
They brought about 800 pounds of dust and rocks back.
Can you
for study.
touch it?
Yeah, there's one rock at the Smithsonian that's sitting there,
Touch it.
and you can touch it, and that's the only one in the world that you can touch.
Is it soft?
Just feel like a rock.
They only let you do
I've touched it.
There's one, and there's a line, and you wait in line, and then you can touch it.
You
Cool,
can
like
only
that
touch it
piece
with
of
one
wood.
finger, though.
Yeah, it's just a little piece that's
They get
showing.
mad at you.
And
Try to grab it.
it's the most expensive rock in the world. It costs even more than diamonds because they don't reckon they can get more of it. You know, they don't want to just lose it and then they don't have it to study. So it's in labs. NASA has it. They're in labs all over the world, and they study this moon rock. And just a little rock would cost you hundreds of thousands of dollars, millions of dollars just for a little rock. So that one that's at the Smithsonian, you can go touch. And that's pretty cool to do.
Do you have to be like a major insider to be able to touch the dust?
To be able to work with it, yeah, you have to. It's all government controlled, so you have to work with NASA. And the NASA scientists still do experiments and stuff on it. But yeah, they brought back about 860 pounds of it or something on the different missions that landed. They scooped up stuff from every part they could find. They scooped up some dark stuff. They scooped up light stuff. They scooped up where there had been impacts. They scooped up regolith. They scooped up everything they could find, and they wanted to study. And one thing they figured out was there's almost no water on the moon. All that dust and stuff is mostly rock. If you dug up dirt from the Earth, there's a lot of water in it. But if you dig up dirt or regolith from the moon, there's almost no water in it. All the water has gone off that was ever in any of those rocks and soil, has dispersed into the atmosphere. There's the only place there's ice on the moon in large amounts is in these craters that are near the moon, that are near the poles. So let's think about the moon here. I'll use this. Wherever the sun shines, the radiation causes any water that's there to evaporate and leave the surface of the moon entirely, because the moon doesn't have much gravity. And so it evaporates, it breaks into hydrogen and oxygen, it's water no more. So the moon quickly became dried out by the sun. But there are craters in the North Pole and South Pole that are deep and in permanent darkness. Sunlight never reaches them. And there's ice there. They thought that there would be, because there's nothing to evaporate the ice. There's no sunlight to hit it and make it hot so it evaporates. So to test to see if there was actually ice in these craters, they flew a mission that goes around the moon, a satellite, that launched a probe into one of the craters. And the probe was just a big thick piece of metal, and it hit the bottom of the crater and made an explosion. And the spacecraft measured what came out of the explosion. And it was a bunch of water. So we know that there's ice in the bottom of those craters. The moon's a cool place. You might get to go there one day because private industries are trying to do that. So who knows, 20, 40, 50 years, and you're an older person, you might go walk on the moon one day. Wouldn't that be cool?
I'm going to do that.
Willis out.